Let's see this question. Gamma is a real number and two lines L1 and L2 are given to you and they're intersecting. Okay, and the R1 is the point of intersection of L1 and L2. O is origin. N denotes a unit normal vector to the plane that contains both the lines. Okay, so it is looking like this, that you have a line L1 here and there is another line L2, let's say like this. They are intersecting at a point, they are calling it R1. And there is a plane which is containing both the lines. Of course, you can have a plane which is containing both the lines. And then there is a unit normal to this plane. This they are calling N. Now, what are they looking for? They're looking what is gamma, what is N, what is R, okay, all such thing. So how do we get started with? Okay, see gamma is sitting here, right here, unknown. So what do we do is we take an arbitrary point on L1. Can you give me an arbitrary point on L1? Let's equate this whole ratio to be alpha. So x coordinate of an arbitrary point will be alpha minus 11. Yeah, you just multiply, right? 1 times alpha minus 11, you get the x coordinate. Similarly, you get the y coordinate to be 2 alpha minus 21 and the z coordinate to be 3 alpha minus 29. Okay. And an arbitrary point on L2, can you give me? Arbitrary point on L2, let's equate it to some other constant beta. So you get 3 beta minus 16 and then 2 beta minus 11 and then beta gamma minus 4. Now, why are we doing that? Because this is an arbitrary point on L1 and there is an arbitrary point on L2. I want both the points to be what? R1. Okay. That means what do? We equate the x coordinate, y coordinate and z coordinate. Okay. So equating x and y coordinates, let's do that. You form an equation in alpha and beta. So you get minus 3 beta is equal to minus 5. Equate the y coordinates, you are getting 2 beta minus 11. Or you get 2 alpha minus 2 beta is equal to 10. Okay. Or you can write alpha minus beta is 5. Okay, all this to get beta and alpha. Okay, let's subtract them. So if you subtract them, you get minus 2 beta is equal to minus 10. So you get beta value to be 5. Okay, and similarly you get alpha value. Okay, alpha value would be from here. Alpha is 5 plus beta, so 10. Okay, so alpha is 10 and beta is 5. Now we haven't equated the z coordinates, right? So let's equate that. Equating z coordinates will get you gamma value. You see that? That 3 alpha minus 29 should also be equal to beta gamma minus 4. Okay. Now you know alpha and beta. Plug in the values. You get 30 minus 29 is equal to 5 gamma minus 4. So you get 5 gamma to be 5. So gamma you get to be 1. So one question we have already answered. Gamma equals to 1. Now, can we quickly also, they see they are also looking for R1. Okay, so do we know R1 now? We do, right? Because now since we know alpha, we know beta, gamma, we can plug in either of them and get the R1 value. So let's plug in alpha value to be 10 in the first one. So 10 minus 11, 20 minus 21 and 30 minus 29. So I got R1 coordinate to be minus 1 and then minus 1 and then 1, right? So what are they asking, you see, in terms of R1? That OR1 is equal to, OR1 is what? Position vector of R1, right? So if R1 coordinate is this, then the position vector is given to you. You just like write I, J and K as a, and these as a coefficient of I, J and K. Okay. So did we get anything? Yeah. Okay. So this is going to 1. The next is they're talking about N here also and here also. What is N? N is perpendicular. Okay, N is a normal vector to the plane containing the two lines. Okay, so now the line 1 has direction ratios to be 1, 2 and 3. You know that, right? These are like direction ratios of line 1. And these are direction ratios of line 2. So L2 has direction ratio to be 3, 2 and 1. We figured out gamma is 1. So how do I get? Okay, so if I take a cross product of these two, then I get a vector which is perpendicular to both of them, right? Perpendicular to both of them means what? Perpendicular to the plane also, that normal to the plane. So let's get going with that then. So I want n vector which is perpendicular to both, I mean the plane which contains both the lines. So I just write 1, 2 and 3. That's the first one, and then 3, 2 and 1. That's the second one. So 3, 2, and 1. So can you solve it quickly? Let's do that. 2 minus 6 minus j, and then you have 1 minus 9, and then plus k, and then you have 2 minus 6. Okay. So you get minus 4i, and then plus 8j, and then minus 4k. Okay. So this is any vector n, but n hat is what? N hat is a normal vector. Okay, so what do? I just divide by its magnitude, right? So divide by its magnitude, how do I get? Okay, so minus 4i plus 8j and minus 4k. So I can divide by magnitude will be what? 4 root 6. Okay, because you can always take that 4 common. Okay, you have 2j and then you have minus k. So this is 4 and here the magnitude is root 6. Okay, so 4 root 6 if I divide, I'm done with. Okay, so plus or minus I could do. Okay, plus or minus 4 root 6. So what do I get? I get plus or minus. Okay, let me write outside plus or minus. Okay, I get 1. Okay, or I upon root 6 plus j upon 2j upon root 6, and then minus k upon root 6. Okay, either plus or a minus. Okay, is anyone? Yeah, this is same. Yeah, if you take a minus sign. Okay, suppose you take a minus sign, because plus means in one direction and minus means in the opposite direction, both are unit vectors. So I upon root 6 and minus 2j upon root 6 and plus k upon root 6. Okay, that is one of the vectors. Then yes, a possible choice could be this also. Okay, now last one. What is OR1 vector dot n unit vector? Very simple, because OR1 you just now got that it is this vector from here. Okay, and you want to take a dot with n hat. So you do component wise multiplication, right, as a dot product. So you get minus 1 over root 6 plus 2 over root 6 and plus 1 over root 6. Okay, so your answer should be 2 over root 6, but we'll see that it is a simplified version, so let's break this down like this. So you get root 2 upon 3, that should be this. Okay, where it is? Yeah, here, this. So everyone matches in the C part of it. Okay, so P goes to 3 like this. This is the correct answer. Nice question. See you with another one.